In the cold silence beyond Earth's reach, two great outposts hang in orbit like beacons of humanity's ambition. One of them, you've heard of. It's the International Space Station, a joint project of the United States, Russia, Europe, Japan, and Canada. It's been up there for over 2 decades, circling the Earth, gathering data, and reminding us what international cooperation can look like. But it's not alone. Above our heads, circling silently and almost unnoticed by much of the world, there's another space station. Its name translates to Heavenly Palace. And inside it, something extraordinary is unfolding. Something bold, intentional, and quietly revolutionary. It's called Tiangong. What's happening aboard Tiangong isn't science fiction. It's not a distant dream. It's real, and it's happening now. But for many outside of China, it's remained a mystery, whispered about in scientific circles, occasionally mentioned in news articles, but rarely explored with the attention it deserves. And when you take the time to really look into it, what you find isn't just a list of scientific experiments. What you find is a clear plan, a future being built, one component at a time, in orbit. Tiangong didn't appear overnight. It's the result of a journey that began humbly, but with quiet determination. Back in 2011, China launched its first space station, a small tubular prototype called Tiangong-1. It wasn't massive, flashy, or packed with international press coverage. It was simple, just 10 meters long with solar panels stretching from its sides like wings. It was a first step, a way to learn, to test, to see what was possible. It didn't need to be grand. Its purpose was to master something essential: how to rendezvous and dock in orbit, how to keep astronauts, or taikonauts as they're called in China, alive and healthy, how to begin. That first station stayed in space for nearly 7 years, long enough to prove that China could not only reach space but live there. Then came Tiangong 2 in 2016, a slightly bigger station with a clearer goal: test the technologies needed to build something larger, more capable, more permanent. Again, it was temporary, a means to an end. And once its job was done, it was brought back down in 2019. That's when the real story began. Tiangong 3, often just called Tiangong, is the final vision made real. Built piece by piece over the course of 2021 and 2022, this new station isn't a prototype. It's a working laboratory in the sky, a floating city, not just of science but of ambition. Unlike its predecessors, Tiangong is modular, meaning it was launched in parts and assembled in orbit. It has three main sections: the Tiana Core module, where the crew lives and works, and two science modules, Wentian and Mengtian. Together they form a living, breathing machine dedicated to one purpose: experimenting, learning, and preparing for what comes next. There are up to 6 taikonauts living there at any given time. They eat from a menu of 120 different foods. They exercise daily to fight the muscle loss that microgravity causes. They tend to plants, conduct lessons for students back on Earth, and even run experiments on fire in zero gravity, because yes, even fire behaves differently in space. At first glance, it doesn't seem so different from what happens aboard the ISS. But when you start looking closer, when you start connecting the dots between all the experiments and all the technologies being tested, a much bigger picture begins to emerge, one that goes far beyond Earth's orbit. Tiangong is not just a science lab, it's a prototype for the future. The experiments on board fall into 5 main categories, and each of them reveals another piece of that future: building in space, autonomous robotics, new energy systems, life support technologies, and spacecraft innovation. That might sound abstract or overly technical, but the reality behind each of those categories is anything but. Take the first, on-orbit construction. That's not just about bolts and beams. That's about figuring out how to build space stations, ships, or even habitats while already in space. Because hauling everything from Earth is slow, expensive, and risky, if you could build directly in orbit or even on the moon, you could skip the hardest part of the journey. And China isn't just imagining it. They're actively developing 3D printing technologies that work in zero gravity. In fact, they already succeeded in printing ceramic parts in space back in 2018. Ceramics might not sound exciting, but they're one of the oldest and most versatile materials humans have ever used. And being able to produce them in orbit could change everything. It means future missions might only need to launch raw materials. The actual structures, the spacecraft, the tools, the habitats, could be built up there. Even more impressively, China is exploring inflatable structures, tent-like habitats that could be deployed on the Moon or Mars and provide shelter without needing massive rockets to get them there. And with robots? The plan is clear. Train them to do in space what they already do so well on Earth. Run assembly lines, perform repairs, move cargo, machines that can work in microgravity with precision and autonomy. It's not about replacing humans. It's about extending their reach, giving them tools that work tirelessly in the vacuum of space while astronauts focus on what only people can do. All of this points in one direction: independence. The ability to build, maintain, and grow a space-based infrastructure without relying on Earth for every screw, panel, and tank of air. Tiangong, for all its elegance and advanced systems, is just the beginning. It's a test bed, a workshop in the sky where China is quietly rehearsing for something much larger, and they're not hiding it. The doors of Tiangong may be closed to certain countries for political reasons, but China has openly invited the global scientific community to collaborate, to send experiments, to share in what's being learned. The problem isn't a lack of invitation, it's a lack of acceptance. Political barriers remain, but the offer is there. What's being built on Tiangong isn't just a space station, it's a stepping stone, a blueprint, a way to prove that living and working in space isn't just possible, it's sustainable, and more importantly, it's scalable. We're watching the quiet construction of a future where humans don't just visit space. They stay, they build, they grow. And they do it not out of curiosity alone, but out of a vision for something greater. And this is just the start. The real question isn't what Tiangong is right now, it's what it's leading to. Because for China, the space station is not a destination. It's a rehearsal space, quietly and methodically preparing for a much bigger act on a much more distant stage: the Moon. Back on Earth, space agencies speak often of lunar bases and Mars colonies, but plans shift with budgets, politics, and changing administrations. China, however, is moving forward with an unsettling steadiness. Every experiment aboard Tiangong serves a second purpose. It's not just to understand microgravity. It's to learn how to live away from Earth, how to make survival in space sustainable, permanent, and eventually expandable. And the scale of what's being tested is staggering. Think about it. On the station, they're working with closed-loop life support systems, the kind that recycle air, water, and waste so efficiently that astronauts can live in isolation for long periods without needing constant resupply from Earth. In space, self-sufficiency isn't just helpful, it's the difference between life and death. They're not only testing how to survive, they're working on how to thrive. Taikonauts are now routinely experimenting with growing vegetables in orbit, not in little trays, not just symbolic science projects. We're talking about developing viable space agriculture, the cornerstone of any long-term space mission. If you can grow food in space, you don't just survive. You start to build a life. And as we speak, Chinese scientists are already applying these technologies to Earth's deserts and barren lands. The crossover is intentional. The challenges of surviving on a sterile rock in orbit mirror those of farming in the harshest environments on Earth. Solve one, and you unlock the other. Tiangong isn't just a space experiment, it's a planetary one. But let's not forget, all of this, the 3D printing, the closed-loop systems, the robotic arms and biodomes, it all points toward a single outcome. China is aiming to build a moon base, and unlike many others, they're putting actual timelines on the table. The plan, laid out in increasingly public detail, calls for the construction of an international lunar research station, possibly with partners like Russia, by the 2030s. Some components of that base might even be robotic at first, preparing the site ahead of the arrival of human crews. But the vision is clear. China wants boots back on the moon. Not just to visit, to stay. And there's a reason for that, one that's more practical than symbolic. The moon isn't just a cold, gray rock floating in space. It's a resource-rich, low-gravity platform. It has water, frozen in shadowed craters, and minerals that Earth is running out of. It's a potential hub for launching missions deeper into the solar system, thanks to its weaker gravity well. If you're serious about building a future beyond Earth, the moon isn't optional. It's essential, and China has been preparing for this for years. Remember the Chang'e missions? They're part of a lunar exploration program that's already placed orbiters, landers, and rovers on the moon. Chang'e 4 made history as the first spacecraft to land on the far side of the moon, something no other nation had accomplished. And most recently, Chang'e 5 brought back moon rocks for the first time in over 4 decades. Those samples are now being analyzed to understand the moon's structure, chemistry, and potential for future human use. All of it ties back to Tiangong. Because the technologies being perfected on the space station, automated assembly, artificial intelligence, energy storage, autonomous repair, are exactly the ones you'd need to set up infrastructure on the moon before humans even get there. We're watching a strategy unfold in real time. And this brings us to one of the most important and overlooked components of China's space ambitions: energy. In orbit, Tiangong runs on solar power. But China isn't just experimenting with panels. They're experimenting with wireless power transfer, the ability to beam solar energy harvested in space down to Earth. That's not science fiction. That's happening now. The implications are massive. Imagine satellites in geosynchronous orbit, collecting clean solar power 24/7, unaffected by weather, night, or seasonal variation, and transmitting it down to Earth as microwaves. Receiving stations convert it back into electricity and feed it into the grid. No carbon emissions, no fossil fuels, just clean, uninterrupted energy. And what's even more astounding is that this system works in reverse, too. Energy beamed from Earth could power machines on the Moon or Mars without needing bulky fuel tanks. It's like creating a cosmic extension cord between Earth and its outposts. If it works, and China is betting it will completely change how we think about power in space. But the innovations don't stop there. China is also refining high-speed space communication systems, experimenting with lasers instead of radio waves. That might sound technical, but the difference is crucial. Lasers can carry more data over longer distances with less power, meaning high-definition video, massive experiment uploads, and real-time coordination between Earth and space becomes not just possible, but normal. If China gets this right, Tiangong will be more than a station. It will be a space-based internet node, a communications relay for missions going farther out, a hub for lunar and planetary exploration, and potentially a gateway for humanity's digital infrastructure in orbit. And perhaps the most revolutionary component of all, quantum communication. China has already become a world leader in this field, launching satellites capable of quantum key distribution, a method of communication so secure that it's physically immune to hacking. It's being tested on Earth now. Soon it will be tested in orbit, and one day it could be the backbone of a completely secure interplanetary internet. That's not just a game changer. That's a civilization changer. When you put all these pieces together, Tiangong becomes something much more than a space station. It becomes a staging ground, a training camp, a design lab, a keystone in a long-term infrastructure plan that stretches from Earth's orbit to the lunar surface and beyond. And yet, the West is only beginning to take notice. Tiangong doesn't get the same press as the ISS. It doesn't host multinational crews or daily video updates. But it doesn't need to, because it's not competing for attention. It's quietly preparing for dominance. In the next decade, the space race may no longer be about whose flag is on what rock. It may be about who can live there, who can build there, who can stay. And so far, China is sending a very clear message. They're not waiting for permission. They're already on their way. There's a feeling you get when you look up at the stars, a quiet awe, a question that hums somewhere deep inside. Are we really alone? Are we really just supposed to stay here forever? For centuries, that question was rhetorical, philosophical. Now it's becoming logistical. It's becoming a matter of time, technology, and trajectory. And China is answering that question not with speeches, but with actions. While others debate, they deploy. While space agencies shift priorities with the winds of politics, China builds methodically, quietly placing one stone on top of another, crafting a vision that no longer feels like science fiction. The most chilling part? It's not aggressive, it's not boastful, it's calm, confident, inevitable. Tiangong, the heavenly palace, is not a publicity stunt. It's a prototype, it's a live test bed. It's China saying, this is how we will live in space. This is how we will explore. This is how we will endure. And as we watch this unfold, it becomes impossible not to ask, what are we doing? Because for decades, humanity's progress in space felt like a shared effort. The Apollo missions, the Voyager probes, the International Space Station, these weren't just national victories. They were global milestones, symbols of what we could accomplish when we dared to look up together. But now the dream feels fractured. The collaborations are strained. The station we built together is aging, and the next frontier may not be a shared one. The truth is, Tiangong isn't just a symbol of China's rise. It's a mirror. It reflects back the choices other nations have made and haven't made. It reflects the years lost to underfunding, the missions cancelled before launch, the warnings ignored. It reflects how we underestimated what was coming next. We often comfort ourselves with the idea that exploration is slow, that nothing changes overnight. But that's not true. The future doesn't wait. It moves forward, whether we're ready or not. Right now, the groundwork for the next era of space is being laid. Not in a distant future, not in secret bunkers, but up there, 400 kilometers above our heads, orbit by orbit, experiment by experiment. Every time Tiangong completes a circuit around the Earth, it silently reminds us, the future is already here. So what does that future look like? It looks like robotic factories in orbit, printing components too fragile to survive a rocket launch. It looks like solar farms beaming energy across the vacuum of space. It looks like quantum-secure networks stretching from Earth to the Moon, immune to interference, unreachable by hackers. It looks like nations not just planting flags on alien soil, but growing food in alien soil, building habitats, raising children, writing laws, forming new cultures in the shadow of distant suns. And if China succeeds, If Tiangong truly becomes the stepping stone to a permanent lunar presence, they will have done something far more powerful than just outpace their rivals. They will have defined the blueprint for civilization in space. It's not just about who gets there first, it's about whose vision sets the rules. What kind of politics will exist on the moon? What languages will be spoken on Mars? Who owns the minerals pulled from an asteroid? Who decides where humanity goes next? These aren't technical questions. They're existential ones. And right now, China is the only nation acting like they already know the answers. And that brings us back to us. What do we do now? Do we pretend this isn't happening? Do we cling to nostalgia for the old space race, for Apollo and Soyuz and Columbia and Discovery? Or do we wake up to the new reality and rise to meet it? Because the story of Tiangong is not just about China. It's about all of us. It's about what kind of species we want to be. One that watches from the ground as history passes overhead, or one that refuses to be left behind. We have the talent, the technology, the imagination. What we need now is the will, because the clock is ticking. Every mission China launches from Wenchang, every new module attached to Tiangong, every experiment that quietly proves a system works, that's a step farther ahead. A step we may never catch up to if we don't start moving now. But this isn't a story of defeat. It's a wake-up call. Because space doesn't belong to one country. It belongs to all of us. But only if we're willing to claim it. The night sky is still wide open, and somewhere up there, floating in the darkness, a heavenly palace orbits the Earth, proof that the next era of human spaceflight has already begun. The question is, will we be part of it? Or will we just be spectators, watching as someone else builds the future?